A very good morning to one and all. So, today we're going to discuss, probably appreciate, a very important topic in engineering graphics. So, it's going to be projection of a straight line. So, when I say projections, you're going to deal with certain entities, probably points, straight lines, then you have polygonal, what do you call it, as a surface, or laminar. So all these, say for example, if it is a point, it is referenced with respect to Cartesian coordinates xy, treating it as a scalar point. Then you have a line which is represented by two extreme endpoints, A, B, as noted, and the AB is infinite unless otherwise you delimit this line AB by means of a dimension so called length. So basically you're going to deal with all these kind of entities, and when looking at all these entities you're going to understand how to project all these entities with respect to the observer's viewpoint. So when I say projection, you're going to deal with a very important projection called orthographic projection. That is, the views of the object or the entity which I have listed here will be projected onto a perpendicular planes, and all those projectors which are called as imaginary lines will also be at right angles to the projection plane. So, for example, if I am going to have, say, a cuboid or cube, a three-dimensional, there are about 6 possible viewing directions. An observer can view from here, which I call it as a front view. Similarly, opposite to the front view will be back view. And apart from that, you have a top view. From top, you observe the object, and also from the bottom. So there are 4, and added to that, you have right hand side view, then you have left hand side. So if you want to understand the definition of this object, which is a 3-dimensional object, but my limitation is I have a 2-dimensional plane, then I have to define this object onto this 2-dimensional plane, which normally used to call as a transformation. And if I am doing that from the right angle perspective to the projection plane, then you call that projection as an orthographic projection. So orthographic projection is nothing but defining the object with respect to different viewing directions. The maximum possible is 6 viewing directions. And with all these viewing directions, you have to ascertain the required number of viewing direction that will completely define this object. Okay, you need not generate all the 6 projections or the 6 views. The required number of views which will be able to define this object, that much views is enough. So when I say projection of a straight line, so first you have to understand the orientation of an object, the position of an object with respect to x and y. Normally we used to call it as a Cartesian coordinate, where z here is a 3rd-dimensional axis. So we are dealing with 2-dimensional object, therefore z is redundant. So here what I am going to do is, first I will explain the positioning and the orientation of these objects. Say this is my x and y axis, which is at right angles. And probably I have 2 different views or the observer is here, he is standing in front of the object, whatever the object, maybe it is a line, point, a cube, or whatever it is. But the thing is, the concept remains the same, where you view the object from the front. This view is called as front view or front viewing direction. The one more is going to be your top viewing direction. Now, when I say I am looking at an object, say for example, a line AB, when I am looking from the top, this A will be projected onto this and B will be projected here. And the projections are marked in lowercase letters, say AB. The length is same because it is parallel to x-axis. But when I am drawing this, I have to project all these projections onto a A4 sheet, which you call it as a plane, right? So what I'm going to do is, say this is I'm converting this into a planar section. Say for example, this is my so this is say X, this is Y, and this plane, which is the horizontal plane, right? So this is the horizontal plane. Say for example, I'm standing on a dais which is horizontal in nature, so horizontal plane. The other one is the vertical. Say board. This board is vertical plane which is perpendicular to the horizontal plane. So now what I'm going to do is, I am placing an object which is parallel to this horizontal plane. Say this is the line AB. You can see this line is parallel to this horizontal plane, and at the same time this line is perpendicular to the vertical plane. So this is what you call it as the orientation. My object is oriented in such a way that it is parallel to one plane, which is horizontal plane, and at the same time perpendicular to vertical plane. This is my definition of the orientation of straight line AB, right? And now there is one more orientation which you can make it like this. Now what this says is that the line AB is perpendicular to horizontal plane. It is perpendicular and it is parallel to the vertical plane. Okay, it is parallel to the vertical plane. So this is another position, okay, another orientation. And when I say position, now you can imagine this is normally we used to call it as the first quadrant. This is second, and this is third quadrant, and this is fourth quadrant. So now you can see my line or the entity or a straight line AB is positioned in the first quadrant, right? It is positioned in the first quadrant. And any object in space, which you call it as a spatial position. So this is in space actually. So normally engineering we used to call space as the fourth dimension, right? Say for example, in an automotive vehicle, the engine is not touching anything, it is supported, it is mounted on a supporting bracket. But the engineering perspective is that we used to call that as a perspective or what you can call it as a dimensional space. Okay, the space provided for accommodating the engine in a car. So this is what you call it as a spatial positioning. Here the object, which is nothing but the line AB, it is in the first quadrant. Okay. Next, how it is being referenced. So we have discussed about the orientation, and next we have discussed about the position. So position is basically first quadrant, second, third or fourth quadrant. And the third is referencing. Say my line AB, this is your horizontal plane, this is your vertical plane. Now you can see the axis X, when it is projected from the front, it will come to here, this point, and axis Y will also be projected here. Therefore, this becomes X comma Y. Okay, in a two dimension. So normally what happens is, this horizontal plane is vertical plane, then you have a line positioned say like this, point A, point B. Now, what is referencing? So, with reference to this horizontal plane, okay, with reference to this horizontal plane, you have the distance of this point A or point B, because it is parallel to HP, therefore you have point A or point B, which is referenced by means of a particular distance. And this distance, I call it as, say this is above HP. See, this is HP, the distance is above HP because the object is placed in the first quadrant. And similarly, what is the position of A when referenced from VP? So, this is going to be my in front of VP. And when I say this is above HP, then the bottom, if it is positioned in the fourth quadrant, any object in fourth quadrant, it has to be referenced with respect to below HP. And here, once again, in this way, that is in second quadrant, it will be like behind VP. Okay. So, any object, it has to follow certain, orientation, conditioning, positioning, and also the referencing. Okay. Referencing with respect to HP and VP. Okay. Then based on these criteria, you have to then follow a procedure for constructing the orthographic projection of these entities, whether it is a line, point, or a three-dimensional object, because the concept remains the same. Okay, because that is basically an orthographic projection. Okay, all the definition of the object, say here point A and point B are the definition of the object, and length is also a definition of the object. So, all these definitions, it will be projected onto a perpendicular plane, whether that perpendicular plane can be horizontal plane or a vertical plane, depending on the three different conditions. One is orientation, the second is positioning, and third is the referencing. Okay. So, with this, probably you will understand and appreciate the basic criteria to understand this problem under this, to understand the problem, to solve the problem and find out the projection of the straight lines, which is oriented and positioned and referenced in different manners. So, this is what you are going to think about. Okay. Now, the other aspects, or what I can call it as, you can prepare or generate a format based on all these conditions. Now, let us imagine there are three different orientations of the straight line and how to generate the orthographic projections for all those orientations. Okay, some basics. So, if you look at, now what I am going to do is say this is, I am going to create okay, this is vertical plane, this is horizontal plane. Okay. Now, if you happen to see, this is a line AB. It is at some distance from HP and some distance from VP. And the other important thing is, you can see this is the boundary. Here you can see the line AB is parallel to HP. The line AB is parallel to HP. And at the same time, the line AB is perpendicular to VP. Okay. And what about this? Say AB. Now, this line AB is parallel to vertical plane, at the same time it is perpendicular. Say, you can see this is the perpendicular to horizontal plane. Now, what about this? You can see with respect to this horizontal plane, it is making an angle called theta. So, what is theta? It is an inclination of this line AB with respect to horizontal plane. Now, there is one more which you call it as the inclination with respect to vertical plane. Say this is line AB. It is inclined at some angle to vertical plane, which is called as psi. Okay, so the other parameters with respect to the orientation, we are going to understand the inclination with respect to HP is theta and inclination with respect to VP is psi. Now, for example, when I am going to draw the projections of AB which is parallel to XY, simply what I am going to do, draw the projectors, right? It will be on the projectors will hit the ground, or what you call it as horizontal plane, right? And you are going to look at this object from different views, as I have already discussed there are about 6 different views, but here you are going to deal with only 2, which is nothing but the front view, and one more is going to be your top view. When you look at the object from top, the exact length will be projected onto the horizontal plane. When you look from the front, this B is visible, A is not visible, point B is visible, which superimposing, and that projection will be a point on the V. It will not be a line, it will be a point. B will superimpose A, and that will be projected onto the vertical plane. So this vertical plane and horizontal plane are the delimiters. Meaning is the projections, it will impinge on these faces. It will not go beyond those faces. And at the same time, these are all the transparent planes, which means you can look the object from bottom also. So it will be like a transparent plane. So now let us go on to this theta and psi. And say for example, if this is my horizontal plane and this is my straight line. Okay. Now this straight line is making an angle, right? Now it is 0. Now it is making an angle. And if you want to view this angle, there is only one possibility, that you have to stand in front of the object. Therefore, any inclination to HP can be viewed from the front view. Therefore, this theta, if you want to look, you have to look from the front. Next, what about this psi? This psi, if you want to if you want to visualize this psi, you have to look from the top. Therefore, any inclination to VP can be viewed from the top view. It can be viewed from the top view. So this is the basic understanding you have to remember. Okay. So after discussing about all these things, I am going to generate a format. As I have told you, the very first thing is finding the common reference line. Say this is HP, this is VP, right? Now this is your common reference line XY. Now this plane, I can make this plane on a A4 sheet, but this is perpendicular to VP. Therefore, I have to rotate this horizontal plane. Therefore, this horizontal plane comes like this. So you will have the basic format, like you will have a common reference line XY. Below XY will be your horizontal plane. Above XY will be your vertical plane. Okay, so whatever the views or the projections you are going to capture or generate, that will be portrayed on this particular format. So this is the first thing you have to understand. Okay, now when I want to include all the very important details of this and generate the views, the first thing is I am going to draw a reference line XY, and I have told you this will be rotated. Therefore, HP comes below this XY. Therefore, below XY will be your horizontal plane, above XY will be your vertical plane. Okay. Now, what about this theta? Theta, I have told you, you can only see when you are looking from the front view. The front view project all the object when you're looking from the front, the definition of the object will be projected onto the vertical plane. And whatever you see from the top, all the definition of the object, it can be a point, it can be a line, whatever the object, all those projections will be falling on the horizontal plane. Therefore, front view will be above xy and top view will be below xy. Now, when you want to look at the inclination to HP, you have to look from the front view, right? Where is front view? It is above xy. Therefore, theta will be, that is inclination to HP will be above xy, and any inclination to VP will be below xy. Next, if you want, say this is my point A and this is HP and this is VP, this point A will be having a distance, I call it as above HP, and this is called as in front of VP. So if I want to visualize this above HP distance, the logic here is you have to look from the front. Therefore, front view, where is front view? Above XY. Therefore, the above horizon HP will be above XY and in front of VP distance will be plotted below XY. So this is the basic thing. And apart from that, once this is the true length of the line, okay, the line will be having a length which is called as true length. The true length will be common to both, because this true length will be making an inclination, true inclination. Here also the true length will be making a true inclination theta. Here the true length will be making a true inclination psi. Okay, and after generating the views, say front view and top view, those two will be having a line. So what is front view? A dash, B dash is your front view, A, B is your top view, where A dash is the projections of point A, B dash is the projection of point B, where A dash, B dash is the front view of line AB and AB is the top view of line AB. So you are going to find A dash, B dash, A, B. So the procedure which you are going to follow will finally give you all the different views which is called it as the A dash and B dash. Okay. And apart from this, there are other dimensions that you have to capture or understand that probably while solving the problem, you will come to know it. So these are all this is the format for solving the projection of straight line problem. Now let us assume there is a straight line AB which is 80 mm in length. Then this point A is fully defined, which is 10 mm from HP, that is what you call it as above HP, and 20 mm in front of VP. So 10 mm above HP, 20 mm in front of VP. It is making a true inclination which is nothing but theta. Theta means inclination to HP as 30 degrees and psi, inclination to VP as 45 degrees. Okay, now you have been asked to find the projections of the straight line AB. So projections. So what is projections? Say projection of straight line AB is front view and top view. Front view is nothing but A dash, B dash, top view is AB. So you are going to find out or construct and find out what is the front view and what is the top view. Okay. So now with the data given and with this format, you just put what is theta P. Theta HP is 30 degrees and theta psi is 45. True length is 80 mm. True length is 80 mm. Then one point is defined. So one point is defined. So I am going to first understand what is that. Above HP distance is 10 mm. Therefore, above HP is 10 mm. And the logic here is A and A dash will be in line with each other. Meaning is this is my front view. Therefore, it is represented by A dash. Now it is in line. Therefore, draw a perpendicular line perpendicular to XY. Okay, now what is IVP distance? It is 20 mm because IVP comes under XY, below XY. Therefore, what is IVP? It is 20. Here it is 10. So IVP is 20 and it should be in line with each other. Meaning is both the points A dash and A will be in line, same. It will be on the same line, but at a distance. AHP above XY, IVP below XY. So this is going to be 20 mm. So this is A. A means A is the projection of point A, capital A, that is the actual line, and this A represents top view. A dash represents front view, and this top and front view of the point A will be in line with each other. Okay, the line joining A dash and A is called as projector line. Okay, the line joining A dash and A is called as the projector line. Okay, it is an imaginary or a reference. Okay, not reference actually, it is an imaginary. Okay, now after drawing this, you have to mark the dimension. So what is the dimension here? It is 20 and here it is 10. See, AHP 10 mm, it is above XY as per the format, and IVP 20 mm is below XY as per the format. Now you have drawn the projection of A. Now what is the what you have to find out is the projection of point B. So now the projection of straight line problem, you are going to follow two important methodology. One is locus and next one is rotating view method. Rotating, normally people used to say this as rotating line, but the correct way of defining this is the rotating view, because you're going to rotate the view and find out the other end projectors, that is B dash and B. Okay, now after drawing this line which is parallel to XY, you name it as locus of, this is A dash, right? Therefore locus of A dash, and here this is locus of A. Meaning is whatever the points, say A1, A2, A3, A4, all will be lying on this horizontal line, which is the locus. And similarly A dash, A1 dash, A2 dash, A3 dash, A4 dash, whatever it is, it will be lying on this locus of A dash line. Okay, so that's the loci. Then next what you're going to do is you look at the other data which is given. True length is given and true inclination is given. So first understand, any inclination to HP, it will be above XY, because in the format inclination to HP, you are going to view this from the front only. Therefore front view is above XY, therefore there only I can draw the inclination, and for which true length is also given. So what is the true length? 80 mm, and inclination is 30 degrees. So take your compass and your protractor scale, whatever it is, measure a length of 80 mm, and incline that line by means of 30 degrees. So say this is 30 degrees. Similarly, you are going to, from the that is below, what is the inclination to VP? It is 45 degrees. So any inclination to VP will be in the top view. Top view, where the top view is located, below XY, right? Therefore here you are going to make a 45 degree line which is measuring once again 80 mm and making an angle of 45, right? So what I am going to do is, after completing this, once again I am going to draw the locus, because locus is one way of understanding that the end points B dash and B will be anywhere on that locus line, right? Therefore, since A is on the locus line, A dash is on one locus line. Similarly, B dash and B will be on the a locus line. So what I am going to do is, after drawing this, I am going to draw a horizontal line which is parallel to XY, and this I am going to mark it as locus of B dash, because A dash, B dash is your front view. I assume that anywhere on this line my B dash will be located. Similarly, anywhere on this locus line of, say this locus line, this is locus of B. Locus of B, anywhere on this locus line my B will be located. So I have to, after finding that A and B will be joined, that is your top view, and A dash, B dash will be joined, that is your front view. Then how to construct or how to find the B dash and A dash. So after give a notation to this, say I am giving it as B1. Since it is above XY, it is a front view, therefore you have to add a dash. So B1 dash. Similarly here I am just giving it as B2. Here no dash because it is top view. And after this what I am going to do is, say for example, this is my actual line which is measuring 80 mm, true length, actual length. Okay, there is no reduction or enlargement of the length. It's a true length. Now when I am looking this line from the top, what will happen? This point will be projected. Already we have got A. And what about B1 dash? That will fall down. It will be projected. And on this locus of A, you will be getting an intersection point which you call it as B1. Now the logic here is, this true length is measuring 80 mm, but the projection of this inclined line, which is nothing but this line, will have a length less than 80 mm. Meaning is, the projection of an inclined line, the length of the projection of an inclined line will be reduced. It will be less than the actual length. So that is the logic. So any inclination leads to reduction in length if it is a line. And if it is, say, concerned with the shape, then there will be reduction in the area of that, whether it is a circle or circle will become an ellipse or whatever, a square will become a smaller square, the area will be reduced. So depending on the entity which you are going to analyze, there will be some reduction in terms of size, okay, some distortion in terms of shape. Okay, now what I am going to do is, once you locate this, follow the same procedure. Here you have put a vertical drop, now you are going to make it as a upward drop. Okay, so upward is B2. From B2, this, when you are looking from here, that doesn't mean that it is the bottom view, because I have told you the horizontal plane, vertical plane, everything whatever you are using here is transparent. So from top itself you look at, so this will be projected because you don't have any plane at the bottom. All this will be projected onto the reference line X and Y. Therefore, you take this up, put an arrow mark, meaning is the line is drawn from the bottom point B2, it is moving up. And similarly here put an arrow mark to convey that it is drop down, it is bottom up, right? Okay. Now this point is B2, therefore here it will be B2. Since it is in the front view, add a dash, B2 dash. Okay. Now locus finished. You are going to look at the rotating views. See, this is a line with a true length, right? I am not rotating this line. I am just projecting the end points of this inclined line, right? I am just projecting. But now this projection is giving my, what is this? Reduced length, which is nothing but the front view. Okay. So this is called as front view length. And what about this? This is called as top view length. You need not confuse because this is below XY. Therefore, anything below XY is the top view. Therefore, this length is top view length. Similarly, above XY is front view. Therefore, this length is front view length. Okay. Now, what I am going to follow, or what I am going to rotate the views, right? I am going to rotate, say, with A dash as center, radius equal to front view length, which is nothing but A dash B2. Draw an arc that will be intersecting the locus of B dash. That point is called as B dash. Now join this A dash with B dash. This A dash with B dash is nothing but your front view. Now if you check this, the front view length and the front view which is generated, both will be having the same length. Now what I actually did, I have rotated this front view. Similarly, rotate this top view, you will be getting an intersection point A, which is nothing but B. Now join this A with B. This is your top view. Now measure this and this, it will be same. Okay, now almost we have completed the problem. But there is one final check we need to do. What is that? Already we have seen that A dash is in line with A. Therefore, the other end projectors B dash and B should also be in line. It should be falling on the same vertical line. For which you need to just join this B dash using a thin line with B. You can see roughly, I have without using any dimensions I have made. Therefore, you can see it is accurately coming, where you can see this B dash and B, they are in the same line. It is falling on the same line, right? Therefore, your answer is correct. Okay, so this is the basic problem. This is a basic problem where you have given true length, inclination to HP, inclination to VP. One end point A is fully defined, that is above HP and below, in front of VP. With this, you have found out what is the front view A dash B dash, top view AB. Now what you're going to do is take a scale, measure it, write the answer. So what is this? Say 65 mm, 70 mm, whatever it is. Now, the other way of checking your problem is this front view length, whatever you are getting, that will be less than the true length. And what the top view length, whatever you are getting, will also be less than the true length. Okay. Now, this front view is making an angle which is called as alpha. This top view is making an angle with the locus of A, and this is called as, this locus of A is logically nothing but xy. Okay, when I am saying angle, it is with respect to xy, but since the points are displaced at some distance from HP and VP, therefore you are drawing this locus which is parallel to xy. So when I saying angle, it means directly or indirectly it is referencing with respect to the reference line xy. Okay, now what is this? This is called beta. Now you see, beta is greater than psi, alpha is greater than theta. This is another check. And the lengths will be reduced because inclined line, projection of inclined line will be having the length which will be less than the original length, true length. Okay, so these two checks we have seen. And the other one, what you can understand is when you add this inclinations, true inclinations, which is nothing but theta plus psi, it will be less than 90 degrees. Suppose if it is more than 90 degree, what will happen is the projectors, that is end points, all the end points, that is A dash, B dash, A, B, it will not align or it will not be in line with each other, meaning is that projections will not be perpendicular to xy. So that is one way of checking. There is one problem where you will have this summation of these true inclinations which will be equal to 90. Therefore, your answer will be like this. So this is A, this is B, A dash and B dash. So you can see 90 degrees to xy. Okay. Now this is the basic problem. So we will work on with another problem because these are all the data. There will be, some data will be given. The format of question will change, but the procedure is similar, only you have to reorder the steps. Okay, you have to reorder the steps. Okay, so let us look into another problem where you will understand how that reordering happens. Okay. Because we cannot use PowerPoint presentations for drawings, you need to use the board. So that will be the correct method, I suppose. Okay. So now let us assume a line AB, say 70 mm. One end A is defined. Say end point A is defined to be means of 35 mm above HP, 30 mm in front of VP. Now, earlier true length and true inclination was given, but in this problem, they have given front view length as 60 mm. Then you have top view length as 40 mm. Now they are asking you to find true length and true inclinations. So first I'll put a format which you're going to follow for any straight line problem, solving straight line problem. So here you can see below xy will be HP, above will be VP, and AHP distance, it will be above HP, will be above XY, in front of VP will be below XY. Any inclination to HP you can see from the front view only. Where front view is located? Above XY, top view will be below XY. Therefore, any inclination you can see it from the front view, that is theta to HP. Inclination to HP is visible when you are looking from the front. Therefore, front view is above XY, therefore theta will be here. Okay, and another one is psi will be here. So true length probably it will be same. The next one which you are going to understand is front view length, top view length. See, top view length is given, front view length is given. They have given the true length also. Then AHP distance and IVP distance is given. So this much data is only given. So now they are asking to find out the missing data, right? And added to this, you can also add some other points, but probably will come to this. So okay. So now what first I'm going to do is I'm going to fix that is I'm going to find the projection of point A, okay, which is clearly defined with respect to AHP and IVP distance. So what is AHP? AHP is located above XY. What is the distance? It is 35. So I'm marking my A dash, and now that projectors will be in line with each other, right? Therefore, I draw a projector thin line which is perpendicular to XY. And from XY, what is the IVP distance? It is 30 mm. So this is 30, which is nothing but A. So A is my top view of point A dash is my front view of point A. This A dash and A is in line with each other. So first step is over. Now you are going to mark the dimensions. So this is 35. There are different ways of annotation, defining the annotation. There are a lot of, there's different formats are being followed. So whichever is up to you, and for a neat presentation you can follow, right? So A dash and A is finished. Now after doing this, I am going to draw the locus, and you know that this is locus of A dash, and this is locus of A. The next step, I know the true length, but I don't have the inclination. Okay, I know the true length, I don't have the inclination, but there is given a front view length is given and top view length is given. Now where is front view? It is above XY. What is that length? 60. So mark here as 60 mm. Okay, and where is top view? Top view is below XY, and top view on that locus, how much you are going to mark? It is 40. So this is 40. This is 40. Okay. See, just I am reordering the steps. So now what I do? I drop down and this up. Okay. Next step. Right? The reverse to the basic problem which we have seen. Because there the true length will be given. Therefore, you draw the true length and true inclination. Then from there you drop down. But here what happens? You are having the view length. Therefore, drop, you have to vertical up and then you have a drop. Okay. And after that, what is the true length? It is 70. Take a compass, measure that 70 mm. From A dash center, cut an arc. And from AS center, cut an arc. So 70 is something like 60. Okay. Now draw this. This is the true length. And draw this. This is the true length. You have the theta. You have psi. Measure it and put it. Now draw this locus. Locus of B dash, and this is locus of B. And this point, draw the locus, and what is this point? Is B2. That means this is going to be our B2 dash. And what is this? Say B1 dash, and this is going to be a B1. After this, what I am going to do? See, this is my front view length. Take this as radius, cut an arc. Then what is this? top view length. This is radius with A as center, cut an arc. Okay? This point is B. This point is B dash. Now join this B and B dash. You can see. So this is how, with respect to, just before even collecting the data, first you put a format, capture all the data from the question, then you will understand how to proceed with the problem and solve the problem. So this is the types. There are around 7 different formats. The question rearranging can be done, but the procedure remains the same. The only thing is, this is the format, capture all the data given in the question, take the data from the question, and then you will solve the basic problem, the first problem which you have solved. Then you will understand how to reorder the procedure. Probably you will be getting the answers. Okay, thank you.